In this video, we are going to talk about recursion. Recursion basically means to go back to something to solve the problem. So I can find my next pattern based on the previous pattern. I can solve a problem by looking at the problem one size smaller, and one size smaller than that, and one size smaller than that, until we get to a problem that is solvable, and we can do all the steps forward to make it solvable to the level, to the scale we were originally trying to solve. So let's look at a more mathematical example with some physical patterns, build up our notation, and then we'll do it in Java. So for example, if I had this pattern with a T made out of blocks, this could be the first in my series of patterns. I could say it's the zeroth. In computer science, we often start at 0, so let's do that. I could start at 1. I just have to be consistent. And the next pattern is going to add to each of the arms of the T. So now I have the T with 3 more blocks added onto it, and it's my first pattern. So in the 0th pattern, we'd say n is equal to 0, and Tn, the term, is 4. We have 4 blocks. In my n equals 1 pattern, we have 1, 2, 3, 4, 5, 6, 7. We have 7 blocks. If I continue to grow the pattern a little bit more, I draw my T, now with 3 additional blocks in each direction. And it was the pattern we had previously with 1 more block in each direction, so we have to add 3 to our 7. And we're starting to see the pattern. The pattern appears to be take the previous term and add 3. So in general, I can say find a new term by taking the previous term, Tn minus 1, and minus 1 because if I'm on the second term, I have to look back to 2 minus 1 is 1, and so on. And to that, I have to add 3. So this is a recursive formula. If I wanted to apply this formula, say I didn't have the pattern to look at, and I wanted to find T1, let's say. We know what it is from the pattern. We know T1 should be 7, but let's just say we're trying to use our formula. T1 would be equal to, according to the formula, T n minus 1, so 1 minus 1 is 0, T0 plus 3. Perfect. So now I can just add 3 to T0 and I know what T1 should be. The only problem is if I only have the recursive formula, I don't know what T0 is. I can't figure that out. That's actually called the base case. It's the initial value we need to have to solve the problem. So along with the recursive formula, we also need to include the base case. So here the base case is T0 is equal to, and if we look back, originally in the 0th place, we had 4 blocks. So T0 is equal to 4. Great. Once we have the base case, then we can calculate that T1 is equal to 4 plus 3, which is 7. If we look back up, we see that that works out. I could figure out T2, T3, and so on, applying the same steps. Say I want to do T3. T3 is equal to T n minus 1, so 3 minus 1, 3 minus 1 is 2, T2 plus 3. I don't know T2, so I need to figure out what T2 is. T2 is equal to T1 plus 3. I don't know what T1 is. I did calculate it over here, but if I was trying to run a program, I wouldn't know what T1 is originally. So now I need to figure out T1. T1 is equal to T0 plus 3. Okay, T0 is a base case. If we have along with our formula that T0 is equal to 4, then I can put in the value of 4 here,